Hi, I'm Li Qianghe from Oregon State University. I will talk about our work, Attention Decomposition for Cross-Domain Semantic Segmentation. The goal of cross-domain semantic segmentation is to predict a class label of every pixel in target domain images, when supervision in training comes only from a source domain, and the source and target images have significantly different distributions. We found the state-of-the-art methods for this task typically use proposal-free transformers. These methods rely on pre-training on a classification task. However, the ImageNet dataset may not include all source and target classes, and the image classification task is different to the semantic segmentation task. In addition, the same class feature distance regularization would lead poor generalization in the cases where the classes are not seen in the pre-training. Therefore, we propose ADFormer, a proposal-based transformer. It aligns the proposals across the source and target domains for better segmentation. As we can see on this pipeline, it retains the ADFormer where the query tokens learn independent class prototypes. ADFormer disentangles cross-attention between the query tokens and the image tokens into domain-invariant attention and domain-specific attention. Another contribution of ADFormer is it splits the ADFormer's head into domain-invariant and domain-specific branches in order to explicitly estimate domain-invariant and domain-specific cross-attentions, and thus enforce the query token refinement to focus on domain-invariant regions that are shared by the source and target domains. Here is an illustrative example of the attention decomposition. The input is the synthetic image, in which the left part is from a target image and the right part is from a source image. For each query token, ADFormer produces a quadruple for it. We found for the top query, the attention map has higher attention on the cars from the target part, and the bottom attention map has higher attention on the cars from the source part. The bias is consistent with the domain prediction of these two queries. However, as we assemble all the masks to get the final semantic segmentation, we would prefer the attention map is domain agnostic, focusing on both two domains. Here are some quantitative results on the GTA to cityscape domain shift. The first column contains the input image, and the remaining columns show the outputs from ADFormer, DFormer, and the ground truth. As we can see, DFormer's output contains many isolated regions of different classes, but ADFormer usually has a more uniform prediction within the object boundary. We hypothesize that DFormer does not have explicit relations for each object, so it is prone to focus on local pixels. However, ADFormer explicitly builds object component relationships by the query token, thus its output objects are more unified within the object, and thus we have less of those isolated object predictions. Here is a comparison of ADFormer with the state-of-the-art methods on the GTA to cityscape domain shift. As we can see, ADFormer outperforms other methods with a clear margin. Thank you for watching.